Hello students and welcome back. You're watching my series on important or expected questions for term 2 that might be asked in the upcoming board examination scheduled for 10th of May 2022. Let us continue with the chapter carbon and its compound, and the topic we are going to take in this video is saturated and unsaturated carbon compounds, also called as saturated and unsaturated hydrocarbons. Now my dear student, this topic is important not only because you might have a direct question from here regarding classification of hydrocarbons, but also because the next two topics that I'm going to take in my two subsequent videos, namely on homologous series and isomerism, can be answered if you know the concept or the basics of this particular topic. Now I'm going to complete this entire topic in the form of question answers. So let's begin. Now you might have a direct question like the one provided here. Now this was a board question sometime back. What are hydrocarbons? With the help of an example each, just one example they're asking, that is Lewis dot structures, also known as electron dot structures that we have already covered, distinguish between alkanes, alkenes and alkynes. Right? So let's split the question. The question says what are hydrocarbons? So you can see hydrocarbons. The word hydro from hydrogen and carbons you can see from carbon. That means they are organic compounds that are composed of only carbon and hydrogen atoms. So any compound, for example, methane, CH4, it is made up exclusively of carbon and hydrogen, and therefore it is a hydrocarbon. So this part is clear. To do this part, alkanes, alkenes, alkynes, what are these, right? Or if you have a question, what are saturated and unsaturated hydrocarbons? Give an example of each. To do these two questions, to attempt these questions correctly, I'm going to give you a little bit of explanation and then we're going to come back to the same question. All right. Now I'm going to quickly explain you the entire classification of hydrocarbons along with how to name alkanes, alkenes and alkynes. So we begin with hydrocarbons. I'm going to use the short form H for hydro and slash C, hydrocarbons. You're not supposed to use this in your examination, your board examination. No short forms like H oblique C. Now hydrocarbons can be classified into two types. One called as saturated hydrocarbons and the other one called as unsaturated hydrocarbons. Now what do we mean by saturated hydrocarbons? Those hydrocarbons which consist of carbon-carbon single bond. Now see, this is one valency of carbon. You know that carbon is tetravalent. It has four valency. So one is here and the remaining three I'm showing as free valency. It's not bonded, okay? You might have hydrogen here, you might have chlorine here, etc. Similarly, like this. So saturated hydrocarbons, how do we define them? They are those hydrocarbons which consist of carbon-carbon single bond. That means all valencies of carbon are satisfied by single bond. Now these saturated hydrocarbons are also called as alkanes. The simplest possible saturated hydrocarbon consists of just one carbon atom, fine, and four hydrogen. So you might say it doesn't have a carbon-carbon single bond, but since it has just one carbon, all the valencies of carbon are satisfied by single bond with hydrogen, and therefore it is also an example of saturated hydrocarbon. More about alkenes I'm going to take a little later. Let's talk about unsaturated hydrocarbons. Unsaturated hydrocarbons are classified into two. The first one is called as alkenes. The second one are called as alkynes. Now alkenes have one or more carbon-carbon double bond. At least one carbon-carbon double bond has to be there to classify a compound into alkenes family. So you have two valencies here and two are free. Can I show it like this? The other one is known as alkynes, which means there has to be one or more carbon-carbon triple bond. So three valencies here, one here is free, one here is filled. They can be represented like this. So you have hydrocarbons divided into alkanes, alkenes, alkynes. So if somebody asks you what is a saturated hydrocarbon, a hydrocarbon or an organic compound made up of carbon and hydrogen in which all the valencies of carbon are satisfied by single bond. What are unsaturated hydrocarbons? Unsaturated hydrocarbons are divided into two, alkenes and alkynes. Alkenes have one or more carbon-carbon double bond and alkynes have one or more carbon-carbon triple bond. Now we are going to study about each of these families independently. So we begin with alkanes. I'm writing a little bigger so that you're able to see clearly. In all these families, namely alkanes, alkenes and alkynes, we are going to do the IUPAC nomenclature, as well as we're going to talk about the structure and the formula of the first 6 members. NCERT says you should know the structure and the formula of the first 6 members of alkene, alkene and alkyne. Let's quickly begin with alkanes. Alkanes, first of all, you need to remember that they have carbon-carbon single bond. So 3 valencies are free, that we've already talked about. Coming on to their IUPAC name, International Union of Pure and Applied Chemistry, that means their official names as of now. The IUPAC name of alkanes, alkenes and alkyne consists of 2 things. One, the word root. Second, the suffix. Word root decides the number of carbon in a continuous chain, straight chain. Okay, that continuous chain I'm going to explain when I'm going to talk about chain, rings and branches. Right now, word root means the number of carbon atoms. Now the word root you need to remember. I'm going to write down the word root for n is equal to 1 to 6, where n stands for number of carbon atom. So if you have 1 carbon atom, alright, the word root is meth. And I'm going to write a dash here because something has to be added later on, okay? If it is 2, it is called as eth. You should learn it with me if you have not learned. If it is 3, it's called as prop. I'm sure you all know it by now. 4, but. Thereafter, number 5, pent. And number 6 is hex. We are not going beyond 6. Now, suffix for alkanes is ane, A-N-E. So if you have carbon atom 1, 2, 3, 4, 5, 6, you have the word root meth, eth, prop, but, pent, hex. And the suffix remain common, that is A-N-E. I'm putting a dash here because something has to be added before this. So it is ane. Now we know the word root, we know the suffix. We need to know the general formula. So how to write that? The general formula for an alkane family is CnH2n plus 2, where n is greater than equal to 1 and n stands for number of carbon atom. So if n is equal to 1, what will be the formula? C1H, 2 into 1 is 2 plus 2, 4. We don't represent 1. If it is 1, we leave it as it is. We write it as CH4. So now you know the molecular formula of the first member. Let's talk about its IUPAC name. IUPAC name comprises of the word root plus suffix anes. Suffix is common, right? So if you have 1 carbon atom, the word root is meth. So first alphabet capital METH. And I'm going to add to the word root the suffix which is ane. Methane. Meth plus ane, methane. If you have 2 carbon atom, right, what will be the formula? C2, substitute in this formula, H6. Now how do we write down the name? Carbon atom 2 means you have the word root eth and we add the suffix ane, ethane. Let's move on to C3, C3H8. 3 carbon atom, the word root is prop, P capital, prop plus ane, and the IUPAC name becomes propane. Simple. But C4H10, right? But plus ane, and you have the IUPAC name butane. Coming on to pent, pentane, the formula is C5H12, hexane C6H14, right? And this is the IUPAC nomenclature. So now you know the first member of alkane family. Somebody asks you what is the first member of alkane family, you know it is methane. If somebody asks you about the fourth member of alkane family, you know it's going to be butane. And if they make the question a little complicated by asking draw the electron dot structure of the fourth member of alkane family. So now you know fourth member means substitute carbon 4, get the formula, write down the name and then draw the electron dot structure. Clear? So this is all about alkane family. Next we have alkene family. Here we are going to be a little faster. For alkene family we have to have 1 or more carbon-carbon double bond. The suffix is ene. You know the word root remains same. If 1 carbon atom, then meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex. Right? So the IUPAC name will be your word root. I'm writing WR as a short form, plus the primary suffix, that is ene. The general formula for alkene is CnH2n. Now, my dear children, you have to have at least one carbon-carbon double bond. There has to be minimum of 2 carbon atoms, then only you can have carbon-carbon double bond. So in the case of alkene, your N cannot be equal to 1. It has to be greater than equal to 2. So you cannot have methene. You cannot have meth, because meth means 1 carbon atom. And in the case of alkenes, your carbon atoms have to be minimum 2. So let's write down the form of table. If we have N is equal to 2. If N is equal to 2, what is the molecular formula of the corresponding alkene? C2, put it here, substitute H4. What is the word root? So word root plus suffix is going to be your IUPAC name. So how do I write it? So this will comprise your IUPAC or official name. 2 carbon atom means it's going to be eth plus the suffix is ene, combine, and you get it ethene. Let's move on to N is equal to 3. It becomes C3H6 for 3 carbon atom. The word root is prop. Combine it with the suffix ene and you get propene. So make sure your A and E are clearly written. Alright. The moment you make it A, it becomes ethane, alkane, right? Ethene, propene, number 4, C4H8, but plus ene, and you get butene, 5 C5H10, pent plus ene, you have pentene, and finally 6 C6H12, little faster, hex plus ene, and you have hexene. Right? So somebody asked you which is the second member of alkene family. Alright? Second member they have asked you. This is the first member. Your N has to be 3. Do not do this simple silly mistake. Your first member has N is equal to 2. So this is going to be your second member. Remember, do not commit this mistake. If they ask you the third member, you're going to substitute N is equal to 4. This is the first member, this is the second member, this is the third member. Alright, let's move on to the next family, that is the alkyne family. Alkynes, right? They have to have one or more carbon-carbon triple bond, right? The suffix is "-ine", this YNE. So this is the suffix. So what is the general formula? You have to have a minimum of one carbon-carbon triple bond. So here also your N cannot be 1. It has to be greater than equal to 2. And the formula is CnH2n minus 2. Let's quickly see the IUPAC nomenclature in the form of table. Let's say N cannot be equal to 1. We begin with 2. Your formula for the simplest alkyne is C2H4 minus 2. It's 2. Okay. Now for 2 carbon atom, your word root is going to be eth. Fine. And your suffix, as already stated here, is going to be ine, and your IUPAC nomenclature, IUPAC name is going to be E capital Ethyne, also commonly called as acetylene. So if you have 3, we go by 3 C3H4, right? 3 carbon atom, it's going to be prop and plus ine, and it becomes propyne. I am sure you can do it until 6 yourself. Alright. So the first member of alkyne family is ethyne, and you should know the electron dot structure of ethyne, which I've already done in my previous videos. You can refer there. Similarly, you should know the electron dot structure of the first member of alkene family, that is ethene. For alkane family, you should know the electron dot structure of the first member methane, second member ethane, and third member propane. Even for butane, you should know, because that is going to help you in isomerism topic. Alright. So this we finished with classification of hydrocarbons. Let us now come back to the same question. The question was, what are hydrocarbons? I've told you, compounds of carbon and hydrogen. The second part is, with the help of an example each, just one example, Lewis dot structure, distinguish between alkanes alkenes and alkynes. So what is the differentiating point? That alkenes have a carbon-carbon single bond, all right? Or all valencies of carbon satisfied by single bond. Alkenes will have carbon-carbon double bond, whereas alkynes will have carbon-carbon triple bond, all right? So you can give one example of alkane, one example of alkene, one example of alkyne, and draw their electron dot structure. So what are saturated and unsaturated hydrocarbons? I've already explained. Saturated means your alkenes having carbon-carbon single bond. Unsaturated means your alkenes and alkynes having carbon-carbon double and triple bond respectively. Give an example of each. They've not asked the electron dot structure. You can simply give an example with molecular formula or simply the name. Alright. So I'm sure you'll be able to do questions that are asked on hydrocarbons and their classification. If in case you have a question like draw the electron dot structure of the third member of alkane family. The first member is methane, second is ethane, third is propane. So you have to draw the electron dot structure of propane. First write down propane, then just split it. Prop means you have 3 carbon atoms. The general formula is CnH2n plus 2. Alright, so C3H6. Am I correct? No, C3H8. How do I remember this? See, first I talked about alkanes, then I talked about alkenes, and then I talked about alkynes. Fine. So alkenes are in between with formula CnH2n. This side we are going to add 2n plus 2. This side we are going to subtract 2n minus 2. So this is the center one, plus 2 this side and this side minus 2. So you can draw the electron dot structure as this, CCC. Fine. 1 2 3 4 1 2 3 4 1 2 3 4, and then you can show the hydrogens. I've already explained this to you in electron dot structure, so I'm a little faster, and just check the duplet is complete and the octet is complete for all the carbons, right? Or there might be a question, draw the electron dot structure for any of these: ethane, ethene, ethyne, butane. So you should be able to do this. With this question, I come to the end of this video. In my next video, I'm going to talk about a very important topic, that is homologous series. We'll talk about how to find the lower and higher homologues. So stay tuned to my channel, keep watching, and let's move on to the next video.